I've been in the ecosystem for quite a while, so I see so many familiar faces. But my name is Tomo, and I'm the founder of WeaveDB, which is a decentralized database on top of Arweave, AO and Hyperbeam. But you've never heard of the actual product. But I promise you, it's going to come out very soon. It's going to be a fully mathematically verifiable, zero knowledge provable database on top of Hyperbeam. But today, I want to introduce something we have been internally using. It's a testing framework called WOW. So it's a, and I apologize first because some of you are in India last month, and the content that I'm going to present today, half of the content is kind of like a duplicate of what I presented in India. But most of you are here for the first time to hear about WOW. So yeah, let's get it started. So WOW is Hyperbeam ready today. So after today, you are going to be able to interact with Hyperbeam and build on top of Hyperbeam using JavaScript SDK. I made it super easy for you to get started with Hyperbeam. So let's get started. All right. So let's talk about developer tools for the ecosystem, right? So we have amazing developer tools like AOS Terminal and AO-Link, which is an explorer from autonomous finance, and AO Connect to interact with AOS process. But those tools are actually used for mostly live AO processes, and these are not for testing. So AO actually doesn't have the definitive development environment for testing. And most developers right now are testing everything against the AO legacy net and Arweave mainnet. But this is not the ideal way to do testing for a largely scalable system. So for example, like Ethereum has Hard Hat and Foundry, which are great developer tools. And I believe the best developer tool creates the best developer community and ecosystem. So I decided to build one myself. So the thing is, like, I was building WeaveDB last year, and one of the integration tests became super slow, and it was taking 3 minutes for one integration test. And if I were to run the same test 100 times a day, I would waste 300 minutes. And I couldn't go on like that anymore. So I decided to build my own testing framework, and which ended up as WOW. So what WOW does is basically 3 things. So firstly, WOW makes your code base very, very concise and small. So the upper black box is how you would write with AO Connect to send a message and receive the result and pick a data from one of the messages returned by the result. So to do this simple thing, you actually have to write so much code, and it's kind of verbose and you know, I thought maybe I could build a framework, like SDK, to give you syntax sugar to make it very, very concise. So if you write the same thing with WOW SDK, it's going to become just one-liner, right? And then WOW comes with a lot of useful tools for your testing. So it's not really easy to track down asynchronous messages and validate the success of your execution because of the nature of asynchronous messaging system of AO. But with WOW, it's going to be extremely easy for you. And the second thing, what WOW does is WOW makes your testing 1,000 times faster. So what WOW is basically, WOW is an emulation of, WOW is basically in-memory emulation of all the AO units and Arweave storage and Arweave gateway all in one place. So when you run a test, your test is going to be run just in memory, which makes it extremely faster. So some of the core developers in the AO ecosystem have been using WOW, and they are validating my claim and with actual numbers, and they are saying it's actually 1,000 times faster testing speed. And then, so WOW is not just in-memory emulation, but there's also a persistent layer with LMDB, which is a super fast key value storage. So you can type a very simple command, npx wow, and you can have all AO units on your local computer in just like 30 seconds. And you can interact with your local net, just like you interact with the AO testnet and mainnet. So since WoW was such a lightweight implementation of AO, I was able to embed everything in the browser. So now if you open up a browser, you have all the AO units right in your browser, which also comes with AOS terminal and local explorer and also coding editor right in your browser, all in your hand. So this makes your debugging very, very easy. So with WoW, you write 3 times less code, you debug 5 times easier, and you test 1,000 times faster for your ultimate productivity. And so WoW is actually just an SDK, which means like if you want to integrate AO units in your applications, all you have to do is to just import the SDK with just 1 line of code. And now you have all the AO units right in your application. So you can do other things as well. You can launch your own local network, which is not mainnet, which is not testnet, and you can let others come to your network for testing, and you can sync with your local file system. For example, you can write everything in VS Code, and then you can sync that code with the browser coding editor. Also, it's Hyper-Beam compatible, so your browser can actually connect with a remote Hyper-Beam node using WebSocket, and also browser-to-browser direct peer-to-peer communication is possible using WebRTC. So you can have AO units in your browser, and others have their AO units in their browser. And you don't have to go through the remote server, but you can directly connect from your browser to other browsers using WebRTC, which creates a mesh network of AO, I believe. So now this is what I wanted to talk about today. It's Hyper-Beam ready today. So it's basically a Hyper-Beam SDK in JavaScript. So what you can do is when you run a test, Hyper-Beam SDK will launch Hyper-Beam node from within your JavaScript testing code, and you can test anything against the Hyper-Beam environment, and you can shut down the node after the test. So this effectively creates a sandbox environment for Hyper-Beam for your testing. So this SDK comes with useful functions. So when you're interacting with Hyper-Beam, it's and the process, it's basically about 3 things. You need to span the process, and you need to schedule a message, and you need to compute the result. So this SDK comes with these functions, and also that's just the half of the Hyper-Beam, and the other half of AO Core is device composition. So you can create your own device, and you can compose that with other devices, right? So to interact with any device, you actually have to construct the right URL to hit the right function on device, right? So you need to understand the path scheme of AO Core, but the path function of SDK will help you to construct the right URL if you know the device and the function you want to hit. And you can send either unsigned message or signed message. So AO Core protocol uses HTTP message signatures, which kind of replaces ANS 104. And all these things are not for you to handle. So this SDK handles so it uses, so you can basically put tags in the HTTP header, and you have to somehow construct the body, and you have to sign it, but this SDK handles it for you. All right, so now we have tutorials for you to get started. So we have tutorials for LegacyNet AOS on Hyper-Beam with local CU. And also, I got the mainnet AOS module working with WAMR and WASI on Hyper-Beam. We also have a tutorial for building your custom device using Erlang, Rust, or C++. And you can test those devices using JavaScript SDK. I mean, of course, you need to write unit test with the language of your device, but when you want to do integration tests with external devices, JavaScript comes in very, very handy, because JavaScript can be a hub between many devices or systems. And also, we are going to have a tutorial on running LLM on top of iOS and even in the browser, because I think it's one of the futures that Arweave is, very promising. And yeah, so that's those tutorials. Actually, those tutorials are incomplete at the moment because I couldn't make it complete by today. So you are going to have these tutorials by tomorrow, and you can go to wow.eco and you can check out the front end app, and also you can check out the documentations. And let's build the future of the decentralized internet together. Yeah, thank you very much for listening.